This is a review of special triangles and similar triangles that will be necessary for you to understand some of the things that we do in trigonometry. I want to start with an equilateral triangle. An equilateral triangle has all three sides and all three angles equal. So this is 60, 60, and the top one's 60, but I'm not going to write it in because I'm going to divide this triangle in half down the middle, which means this would be 30 and this would be 30. And this is a right angle. Now, let's say I made the sides all equal to 2 units long. Well, I just divided the bottom in half using this altitude, so I'm going to call this 1 and this 1. So we had an equilateral triangle with all the sides 2 and all the angles 60, but I've divided it into 2 pieces. And this is where the special triangle, the 30, 60, 90 special triangle comes from. So let me just take 1/2 of this. So here's 30. Opposite 30 is the side of 1. Opposite 60, we don't know yet. And the hypotenuse, which is opposite the 90-degree angle, is 2. Now, how do we figure out what the missing side is? We use the Pythagorean Theorem, which says a squared plus b squared equals c squared, or the 2 legs squared added together is equal to the hypotenuse squared. So let's call 1a, 1 squared, plus our question mark would be b. We'll call that b. So 1 squared plus b squared is equal to 2 squared. So this will be our c. So b squared is equal to 2 squared minus 1 squared, which is 3. So b is the square root of 3. So our 30, 60, 90 triangle has these ratios. And I'm going to draw it sideways now instead. If this is our 30-degree angle and our 60-degree angle, opposite the 30 is the smallest side, 1. Opposite 60 is the square root of 3, and the hypotenuse is 2. It is very common for students to get the square root of 3 and 2 mixed up and call it 2 and the square root of 3, or switch the sides. Make sure that when you do the a squared plus b squared equals c squared, the Pythagorean theorem, that the sides, that ends up being true, or else this is you've made a mistake. The other special triangle is a little easier. It's a 45, 45, 90 triangle. So when you have a 45, 45, 90 triangle, when you have equal angles, the sides opposite those angles are also equal in length. So we're just going to call each of those 1. And using the Pythagorean theorem, we have 1 squared plus 1 squared equals c squared. The hypotenuse, 2 equals c squared. So the square root of 2 is c. So this is the square root of 2. So those are our 2 special triangles. That's where they come from. Now I want to extend this a little bit and talk about similar triangles, because I kind of arbitrarily picked that I wanted the shortest side in both these triangles to be 1, but it doesn't have to be 1. We could just call it x. We could say that in my 30, 60, 90 triangle, for example, that the shortest side is x, in which case the hypotenuse would be 2x, and the other side would be the square root of 3 times x, because as long as the angles are the same, the triangles are similar, which means the ratio of their sides are equal. In other words, I can multiply or divide all 3 side lengths by the same number, and it's still the same angles in the triangle. And this is going to come in handy for something we need to do in trig. So here I'm going to have x, x, and the square root of 2x for our 45, 45, 90. Now, let's say that for some reason I want the hypotenuse to equal 1. And the reason I'm going to want the hypotenuse to equal 1 is I'm going to be able to embed this triangle in a unit circle and have that hypotenuse represent the radius of the circle, because a unit circle has a radius of 1. So if I want this number to be 1, then x is going to have to be 1/2. So if I make x 1/2, then I have a 30, 60, 90 triangle that looks like this. 1, 1/2, and the square root of 3 times 1/2, which is the square root of 3 over 2. So there's my 30, 60, 90 triangle. My 45, 45, 90 triangle, if I want to have have my hypotenuse equal 1, then x would have to be 1 over the square root of 2. So that would leave me with 1 as my hypotenuse, and since x is 1 over the square root of 2, those would be my two legs. And because we often don't like to have the denominator left with a radical in it, we can also do what's called rationalizing the denominator. We take 1 over the square root of 2, we multiply it by the square root of 2 over 2, which is just a form of 1, and we get the square root of 2 over 2, because a square root times itself is just what's inside. So this is the square root of 2 over 2. That's an alternate way of writing it, and probably the more common way of writing it. Now, I'm going to be able to use these triangles then to find trig values. So we're going to talk about that in the next video.